I'm Raaja Santhosh, and with my teammates Viswasurya and Umar, we made a project based on 8051, which is fire detection system. I'll explain the overview of the workflow and the inputs and outputs that we got, and the components we used, and the interfaces we used, and everything. Viswasurya will explain the code, and Umar will explain the working demo of the project. So this is our project's complete design. So here we took port 2 and port 3 as output and port 1 as input signals. So in port 1, we we attached flame sensor and gas sensor. So these two are the input signals basically. And in flame, like in port 1.0, we added a flame sensor. Between port 1.1, we added gas sensor. Now going to the output ports. So this whole port 2 acts as a data pins for LCD, and then in this port 3, we port 3.2, 3.3, and 3.4 are connected to RS, RW, and E, which is which is responsible for writing and writing and reading in the LCD. So next in the port 3.0, we inserted LED, and then in 3.7 we added servo motor, which is responsible for opening the emergency exit. So this is the workflow of our project. Like first we'll initialize the LCD commands and then all the ports and everything. Next, the LCD first will show the title, and then we will initialize the clock basically. So with this, the current time will be shown. Next, our fire detection system, it checks for flame. If flame is detected, then the gas will get checked. Even if gas gets checked, then then critical will display in the LCD. So this what indicates that the amount of flame and the fire is high, so immediate action should be taken. So the servo motor will get on. So basically the emergency exit will open, and then the LED will have a fast blink, like approximately 250 milliseconds. If if the flame is checked and then gas is not checked, then it'll just sorry. If the flame is not checked, it'll check for the gas, and if the gas is checked, then only the gas will be printed, and the LED will blink for 5 seconds. Next, again it will go for checking the flame, and this time if it gets checked, like if flame gets checked and gas doesn't get checked, then it'll just show flame, like a fire is detected, and LED will blink for 1 second delay. So all this thing will happen repetitively. So Vishwasurya will explain the code.
This is the program for our fire detection project. In the main function, we have we are loading the LCD command sequence into the DPTR, and we are setting up every single ports according to our needs, and we are initializing the stack pointer too, and we are calling the initialize LCD command, and then we are moving the required hour, minutes and seconds into the each registers. We can change it, so we can set at what time does the clock starts. For example, if I make it 12, it starts at 12 o'clock. C1 is the loop command that sends commands to the LCD, and check sensors. This is the main one. Are both the MQ2 sensor and the IR flame sensor work on active low logic. So we are using JNB instead of JV. For example, if P1.0, which is the flame sensor, is active, it checks gas, and if it is gas is also active, then it says it's critical. But if gas is not active, it goes to send flame, where it loads the my data. My data is nothing but flame, I guess. Yeah. My data is nothing but flame, which gets loaded into DPTR. And similarly with gas leak, gas data is gas, and then it short jumps to display message. Display message is also a simple loop for displaying what message we have stored in the DPTR. As you can see, standard stuff for the LCD. So similarly, we have another one which is called send no data. When there's no data being sent, we are showing the time clock that we have initialized in the registers here, and we increment it every second. Also, you can see that in the display message we are checking either one of these are not active. If not, it won't start the servo. A call it is actually start servo. When we go to start servo, it gives a 1 to 2 millisecond pulse to the servo motor, so it starts spinning, and it stops eventually, which is what we are doing here. Common write is pretty simple stuff. It moves data from the accumulator to the LCD data pins. Data write is also simple stuff. It moves the data from accumulator to the data pin of the LCD. This is for sending the initialization stuff. This is for displaying time. All of these are for the same clock displaying only. And then we have main one. This is for the LED control. As you can see, display in the display message itself, when accumulator becomes 0, it jumps to main one. Main one is nothing but the initialization of the LEDs. So we can again we check the sensor to make sure that what kind of state the sensors are in, and then if there is no temperature, the port 3.0 where the LED is kept is disabled, and if it is high flame, it blinks every second, and if it is gas is being sensed, it blinks every 5 seconds, and if not, if both are being sensed, it will blink every 250 milliseconds, basically blinking continuously. And these are the delay subroutines, basic stuff for delay 20 milliseconds delay for the clock, and then finally the LCD commands, uh, flame, gas, critical, and normal. Yeah, that's it. Now on to Santosh for the PPT. Thank you.
Now for the inputs and outputs, we took digital input from flame sensor and MQ2 sensor. So these two acts as like whenever the flame sensor gets high and MQ2 gets high, we will get input signals. So the output is based on which input we are getting. Let's say LED blinks based on the input signals, and then the alert message based on the situations. Like if flame is detected, flame will be printed, and gas is detected, gas will be printed. If both of them are detected, uh, then critical will be printed and emergency exit will open. And see this is if fire and smoke is detected, then emergency exit will open. Now this is like the implementation of the kits. We used 8051 development board. So this is like the main board which controls all the sensors, and uh, and basically we'll program it, and then we will like as a, we'll program it, and then it will do the required job. So flame sensor is to detect the presence of fire, and then MQ2 sensor is for the gas leakage or smoke, and 16:2 LCD displays to show the system status, time, and the fire alerts. So this LED is for indicating the situations based on the blinking patterns. And servo motor is used to open the emergency exit when both fire and gas is detected. And the power supply, and we also use power supply and breadboard for our connections and the power source. So this is our live real-time project. Umar will explain the working of the project.
During the normal state, the LCD acts as a digital clock. When flames are detected, the LCD shows flame and the LED blinks at an interval of 1 second. When the gas is detected, the LCD shows gas as the output, and the LED blinks for 5 seconds delay. When both gas and flame is detected, the servo motor works and opens the door. And the LCD shows critical, and the LED blinks for 250 millisecond delay.
So the practical applications where this can be implemented. So we can, as like we are using only 8051, and then the sensors like this occupies like very small amount of space, so we can use this as smart safety system in small buildings, let's say uh, like in our houses or some tuitions or clinic or what or somewhere like that. home automation. So this is for home. You can use it for home automation also, like automatic fire detection system when we are like having a smart systems for everything. And then fire safety in laboratories. Let's say like in research areas and in like colleges, classrooms, and everywhere in the labs and all. If it's like fire prone areas, so we can use them. And then in the factory, storage rooms, and warehouses. So scope for future enhancements. So for now we added MQ2 and flame sensor, which will detect both smoke and fire. So this can be enhanced in futures, like by adding GSM module for SMS alert, like not only LCD, but we'll get SMS alerts also. And if we are adding Wi-Fi and Bluetooth module, then we will get what it can automatically trigger the emergency alert system, and we will also get notified faster. And then auto water sprinkler trigger. So this is for like instead of like not instant, like with emergency exit, we can even add this water sprinkler trigger, which will automatically trigger water sprinkler and turn off the fire. So this is our project. And thank you.